Hi future doctors, welcome to the next class. In this class, I will try to give units and measurements. I will try to give all what we discussed in one video. So we will see how many problems you can solve by listening this video. So units and measurements, in this first we will discuss about dimensional formula. So any dimensional formula you can write if you remember either definition or equation or units. Let us assume velocity dimension form. So velocity is going to be definition distance by time. Equation also same distance by time. Units meter per second. Now what is the distance? We will represent L. Time we will represent T. So these are nothing but fundamental physical quantities. Meters L, seconds T. So L by T. Therefore, velocity dimension formula is L T power minus 1. The powers of this fundamental physical quantities, L power 1 is there. Here T power minus 1 is there. These two we will call dimensions. Dimensions of length and time for velocity. If you want to write force, what is the force dimensional formula? What is the force definition? Rate of change of momentum according to Newton's second law. So dp by dt, change in momentum by time. Units, Newton. So Newton is the unit, but it is coming from this equation. How this equation is coming means momentum units. What is momentum equation? Product of mass and velocity. Kg meter per second per second. So kg meter per second square. That is going to be kg meter per second square. That is going to be the unit. So therefore, if you are writing like this, kg m meter L per t square. So ml t power minus 2. This is the dimension formula for force. M power 1, L power 1, t power minus 2. How they are going to ask in competitive? So force dimension formula n power x, L power y, t power z. Find x plus y plus z. X, y by z. How much they are going to ask? Now what is x value from this? 1, 1 minus 2. Therefore 1 plus 1 minus 2, 0. In this x into y, x into y means 1 into 1 divided by z is going to be minus 2. So 1 by minus 2. They are going to ask like this. So here like this n number of dimension formulas will be there. So all these you can solve just if you remember that either definition, equation or units. Now what are the uses of this dimensional formula? So to convert from one system to another system, to check the correctness of the equation, and to obtain the relation between physical quantities, and last one to change one system to another system of units. So these are the uses of dimensional analysis. Now see how we can check the correctness of the equation. They will give an equation f is equal to m v square r, v is equal to root g by r. Let us say so. So whether these two equations correct or wrong, we can check. To check, we have to take LHS, force dimension formula, ml t power minus 2. So mv square r, mv square r, mass dimension formula m, velocity L t power minus 1 whole square, r is nothing but distance. Therefore m L square t power minus 2 L. So m L cube t power minus 2. So LHS is ml t power minus 2, RHS is ml cube t power minus 2. Therefore this equation is going to be wrong. Now coming to this equation, what is LHS here? Velocity is L t power minus 1. What is RHS? G is nothing but acceleration due to gravity, L t power minus 2. R is radius, so t power minus 1. So this is also not correct, isn't it? So this is We are checking the correctness of the equation. Now see the second relation. Means second use, obtain the relation between physical quantities. Obtaining means now this is wrong. What is the correct relation? So to get that, so whatever they are going to give first, f is directly proportional to, so m power a, so v power b, r power c. Now force dimension formula you can write ml t power minus 2. So m power a, velocity dimension formula l t power minus 1, radius l, whole power c. So ml t power minus 2. So m power a, l power b, t power minus b, t power c. So ml t power minus 2. So m power only a, l powers b plus c, t power minus b. So if we compare, a is equal to 1, so b plus c is equal to 1, so minus b equal to minus 2, then b is going to be equal to 2, and b is 2 means 2 plus c is going to be 1, c is equal to 1 minus 2. So c value minus 1, is it visible? C value minus 1. Now substitute in this equation. F is directly proportional to m power a value 1, v power b, v square, r power minus 1. Therefore, f is equal to mv square by r. This is the correct relation. Like this also, you can check this equation. Next, to change from one system to another system. So 1 Newton is equal to how many dynes they are going to ask. So we came to know 1 meter is equal to how many centimeters? 100 centimeters. This is n1 value, this is u1, this is n2, this is u2. So n1 u1 equal to n2 u2. So numerical value is inversely proportional to u. So nu equal to constant, they will write. Numerical value. If you are increasing or decreasing the units, value also either it is going to increase or decrease. So meter or centimeter. Meter is going to be largest unit. Centimeter smallest unit. So if you are decreasing the unit, numerical value is increasing. Therefore, relation between numerical value and unit. So they will ask what is the graph, n and u graph. So inversely proportional means rectangular hyperbola. Sometimes they will ask n and 1 by u graph. This is directly proportional. Sometimes they will ask nu graph. So it is constant. So anything they may ask. So by using this, 1 Newton is equal to how many dynes? So Newton dimension formula 1 kg meter per second square. So N2 dynes gram centimeter per second square. So this kg you can convert into gram. Otherwise gram you can convert into kg. Is it visible? Yes. Now right here 1. What is kg? 1000 grams. Meters 100 centimeters per second square is equal to n2 gram centimeter per second square. Gram centimeter will be cancelled. Then n2 is going to be, so 10 cube into 10 square. So 10 power 5. So n2 value 10 power 5. Therefore 1 Newton is equal to 10 power 5 dynes. This is how to convert from one system to another system. So 1 kilometer per hour is equal to how many meter per second? So kilometers you can convert into meters, hours you can convert into seconds. You will get 5 by 18. So this is the formula further. And next in this very important relation, homogeneity principle. So according to homogeneity principle, so z is equal to x plus y rod. So dimensionally z equal to x, z equal to y, and x equal to y. So if you want to use an example, v is equal to u plus at. So velocity is equal to velocity, and velocity should be equal to dimensionally at, and u also should be equal to at. So you can cross check dimension formulas. Lt power minus 1 velocity. Acceleration Lt power minus 2 into t. So that is also Lt power minus 1. Therefore this one and at all are having same dimensional formula. If you want to check this one also, you can see ut plus of at square. So s is equal to ut. S is equal to at square, and ut should be equal to at square. So constants, it will not give any information. So distance L, ut. So L t power minus 1 t. So that is also going to be equal to L. So S equal to L, a t square. L t power minus 2 into t square. That is also L. So this one also you are going to get same. So this is about homogeneity principle. How they are going to ask questions on this? Velocity equal to at plus bt square plus c. Find the dimension formula for a, b, c they will ask. At the time, velocity should be equal to at. A equal to velocity by time. Lt power minus 1 by t. So Lt power minus 2. So velocity equal to bt square. Then what is b? Velocity by t square. Lt power minus 1 by t square. So Lt power minus 3. And velocity equal to c. C equal to Lt power minus 1. In place of this velocity, you can replace theta. Theta is having no dimension formula. Theta is equal to at plus bt square plus c. Then theta equal to at, theta equal to bt square, theta equal to c. So theta is dimensionless. 1, 1. From this a is equal to 1 by t, t power minus 1. From this b is equal to 1 by t square, t power minus 2. So from this c is going to be dimensionless. So like this they are going to ask by using homogeneity principle. You can replace this velocity with force. Whichever physical quantities you are going to place, some new questions are going to be coming. Next, limitations of dimension analysis. We said uses. Now, where we cannot use this dimension formulas. So, we cannot say about constants information. Now, kinetic energy is equal to, we will write half mv square. We cannot give any information about half. In this equation, half at square. So, we cannot give any information about half. And in any relation, trigonometric functions are there. Y is equal to a sine omega t, let us assume. So, any trigonometric functions are there and exponential functions are there. E power beta x and logarithmic functions are there, log kx. We cannot give any information about those also. So, constants, trigonometric, exponential and logarithmic functions. We cannot give any information. So, for the dimension formula, generally we will take 1. How they are going to give questions on those, we will see some examples. So, let us assume they gave y is equal to a sine bx. So, what is the dimension formula for x? They will give. What is the dimension formula for b? They will ask. Okay. So, at the time sine bx is going to be 1. So, bx is going to be 1. B is going to be 1 by x. L power minus 1. X is going to be distance. Same question if they ask like this. A sine bt. Then what you are going to get? So bt is going to be 1. So b is going to be 1 by t power minus 1. So dimensionally, this one you can take it as 1 whenever they are going to give. And y should be equal to a. If a is constant, y is displacement, then a dimension formula is going to be L. So logarithmic function also same. So y is equal to a e power minus beta t. What is the dimension formula for beta? They will ask. At the time, this exponential is equal to 1, beta t is also equal to 1. Beta is 1 by t power minus 1. Even logarithmic function also same. Y is equal to a log kx. For understanding purpose, repeatedly I am taking same. Here k is constant, x is distance. Then kx equal to 1, k is 1 by x, L power minus 1. And dimensionally, y is also going to be equal to a. Next, in homogeneity principle, we said z is equal to x plus y, and we can write x minus y also. Same physical quantities can be either added or subtracted. So y is equal to a sine omega t minus kx they will give. So what is the dimension formula for omega by k they will ask. At the time, in between what is there? Minus. Whenever minus is there, you can equate these two. So omega t equal to kx. Omega by k equal to x by t. L by t, L t power minus 1. So dimensionally this entire thing we can take it as 1, then y is going to be equal to a. So like this they will be asking the questions. You have to do very carefully. V is equal to at plus b by t plus c they gave. Let us assume. At the time v should be equal to at. A is v by t. Lt power minus 1 by t. Lt power minus 2. Same like that. C and T is going to be added. Therefore, dimensionally, C is going to be equal to T. And if you want B, V is equal to B by T plus C. So, denominator thing is going to be equal to dimensionally T and C. Both are going to be same. That is going to be T. So, B by T they will get. So, then B is velocity into time. Lt power minus 1 into T. That is going to be equal to L. Correct? So, you can cross check once, but how we are doing in fast way. So what we discussed in 10 minutes, now we are going to discuss all in one shot, isn't it? So this is about dimension formulas limitations.